Hi everyone, today's lesson is lesson 50 and we're going to be covering two really important math topics today. The first one I'm going to just kind of go over quickly, but it's worth me talking about. And the second one is kind of an expansion of something that we started to practice at the end of last year. So the topics are looking at decimal number lines, looking at tenths and how to represent that as a decimal, and then dividing by a fraction. So when we start to do work with division of fractions, some of you might remember we used some terms like keep, change, flip, or keep it, change it, flip it. We're talking about multiplying by the reciprocal. That's how you do work with dividing by fractions. But I'll show you a little bit more about that when we do some practice problems. Our learning targets for today are exactly what I just said. So the first is to locate and identify decimal numbers on a number line that are divided into tenths. And then the second is to divide a whole number by a fraction by multiplying the whole number by the fraction's reciprocal. So looking at a decimal number line, we've been doing a little bit of work with these already. Just to review, remember when you're taking a look at a number line and you're counting the tallies between whole numbers, remember that you always begin counting tallies at the tally that follows the whole number. So when I'm starting to count tallies, I start with this right here. I don't start right on the whole number. I start with the one that is right after it. So I know that they already told us that these are divided into tenths, but I'm going to count just to show you. We start here. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the final number that we're counting, when we're counting tallies in between whole numbers, that final number is counting the next whole number. So this is indeed divided into tenths. They're asking us to identify where the arrow is pointing. So just to give you an idea, just to go back and double check, we have 1, 2, 3. So this represents 3 tenths. And the whole number that falls right before the arrow is 1. So if I were to represent this as a decimal number, we would be talking about, if I need to get my pen, we would be talking about 1 and 3 tenths. Because of course the tenths place occurs one place right past the decimal. That's exactly how you would write this number. Here's another example right here. We're looking at y on this number line. Go ahead and pause this, give this a try, and unpause when you're ready to check my answer. All right, so if you counted correctly, the correct answer for y, actually, if I were to label this even better, I would say y equals 7 and 4 tenths. Now we're going to take a look at multiplying by the reciprocal, or basically dividing by fractions. So looking at this example right here, we're not looking at a straight up equation, we're looking at more of a story problem. And this, if your brain works like mine, I have a little bit of a harder time with story problems because I always overanalyze them. I'm always trying to make sure I have my information correct. My brain prefers just a straight up equation, but regardless, these are really important to understand how to interpret. The question is this: how many quarters are in $3? So really, we start by asking ourselves this question. We have $3. How many quarters are in $3? So we're dividing $3 and to find out how many quarters are in there. To solve this problem, they're saying we can multiply by the reciprocal of this. And actually, that's at the bottom of the slide. Multiply by the reciprocal. Well, we're going to keep, change. Change means we change our multiply sign to, or division sign to a multiply sign, and then flip. So the flip, or the reciprocal of the fraction 1/4, if we flip that upside down, we have 4 over 1, which is the exact same thing as 4. 3 times 4 is 12. Let's make sure that this is a reasonable answer. 12. What are they really asking us? How many quarters are in $3? 12. 12 quarters in $3. Well, 4 quarters in $1, 4 quarters in another, 4 quarters in the third. Yeah, that's reasonable. That's correct. 12, and they're asking us about quarters. Just for time's sake, I'm just going to use a Q. 12 quarters. Labels are important. Let's look at this next example right here. I literally, before I started filming this video, I had to read through this problem twice to make sure I was reading the information correctly. Here we go. This row of pennies is 2 1/4 inches long. The diameter of a penny is 3/4 of an inch. How many pennies are needed to make a row of pennies 6 inches long? So we're starting off really, actually, you know what? Go ahead and pause this. I'd like to see if you can solve this on your own without any walkthrough. Try this on your own. See if you can get an idea for what the correct answer should be, and please unpause when you're ready for me to talk through the answer. Okay, so they're asking us how many pennies at 3/4 of an inch each diameter would we need to create a row of pennies that is 6 inches long. So ultimately, the question that they're asking is 6 divided by this 3/4 of an inch. How many pennies? And they're telling us to solve this, we're going to multiply by the reciprocal of this fraction. So instead of this, I'm going to rewrite this problem like this. Keep, change, now flip. The flip, or the reciprocal of 3/4, of course, would be 4/3. I'm going to actually rewrite this problem a little bit better. I didn't mean to do this, but I happened to write my 6 kind of small right here, which set me up to do just add to this. Instead of just writing 6 as a whole number like this, I'm actually going to represent it like a fraction, because my brain likes to work. If I'm working with fractions, I want everything to be in fraction form. It helps me just better understand things. Is it absolutely necessary? No, but it just helps me, and it might help you too. So instead of writing 6 like this, I can represent 6 as a fraction. We can do that to any whole number at any time. All we have to do is put a 1 in the denominator place. So instead of 6, I'm going to do 6/1. And now I just have a fraction multiplication problem. I have 6/1 times 4/3. I really like cross-reducing. I know that we're working with smaller scale numbers here, but when we start to work with larger scale numbers, this really makes a difference. So when I cross-reduce, I take a look here at numbers that are diagonal, numbers that are across from each other on the diagonal, and ask if they have a common factor. Now, 4 and 1 do not. Once one of your factors is 1, there's nothing that you, or one of your numbers is 1, one of your factors, there's nothing that you can reduce. But these two numbers right here definitely have a common factor, 6 and 3. Their common factor is, in fact, 3. So I'm going to cross that off, and 3 divided by 3 is 1. 6 divided by 3 is 2. Now I'm working with smaller numbers to multiply across, and I'm going to save myself some math. So now I have 2 times 4 in my numerator's place, and I get 8. And in my denominator's place, I have 1 times 1. And I have 8/1. And the better way to write that answer is 8. Now, before we're done, we're going to go back and ask ourselves if this answer is reasonable, and we're going to find out what is the most appropriate label. How many pennies are needed to make a row of pennies that is 6 inches long? Yeah, that's reasonable. 8 pennies. That seems about right if they're each 3/4 of an inch. Yeah. So 8, and then how many pennies? Our label would be pennies. For time and space sake, again, I'm only going to do a letter P. 8 pennies. Okay, so that's all for your examples for today. With these, just, I don't know, my best advice for you, try not to overthink these. Think about what they're asking you basically, and then work from there. So their basic equation you're going to start off with, and then solve it by multiplying by the reciprocal.